Hello there viewers. So today I am going to perform an experiment to find out the unknown mass. So this is our unknown mass and we are supposed to use the parallelogram law of vector addition to find out the unknown mass. For that we require some known mass, and these known masses are 50 grams each, and I am going to put it inside the hanger. And then we have this wooden board on which two pulleys are attached at both the ends. Then we require a mirror. This is a plane mirror, and we require some basic stationery, and we require a thread in which there are three knots like this, one at the center and two at the edges, like this one and this one. So this is the basic setup. Now let's have a look at the theory first before going into the practical portion. In parallelogram law of vector addition, I am going to take two vectors. This is, say, vector F1. The second vector is F2, and these are the heads of the vector, and I have drawn in such a way that their tails are joined together. Now the angle between both the vectors is theta. Now what am I supposed to do is, I am supposed to construct a parallelogram, and I'll be constructing exact replica of F2 over here, because in the parallelogram the opposite sides are equal. So I'm going to measure the length. This is approximately 6.5, so 6.5 centimeters from here, like this, and again the arrow pointing in this direction because these two vectors should be identical. So this is again F2. In the same way, I am supposed to construct this F1 vector whose length is 4.2 approximately. So this is again 4.2. So I have completed a parallelogram. So those two vectors which are supposed to be added, make sure this is F1, make sure their tails are joined, and then you can measure the angle between both the vectors. Now the parallelogram law of vector addition states that the diagonal coming out like this is the resultant vector, but the diagonal should be coming out from the intersection of the tails from here. So you cannot actually construct a diagonal like this and say that it is a resultant vector. No, this resultant vector is, say, Fr, and this resultant vector is the resultant of F1 and F2. Right? So this diagonal of the parallelogram is the resultant vector. Now the value of the resultant vector is equal to under root of F1 square plus F2 square plus 2 F1 F2 cos of angle between them. This is the formula for finding the resultant vector. So theta is the angle between them if their tails are joined together. So you may substitute all the values over here and you will get the resultant vector. Now this experiment is carried out on the basis of this particular law. Now what am I going to do is, I'm going to take the entire setup, I'm going to mount it on the wall, which we had already seen, and in this you are seeing two pulleys like this one. So there is one pulley over here and there is another pulley over here, correct? Now I have already shown you the thread, that how does it look like. So there are three knots in the threads like this, and then I am supposed to hang the weights. This individual weight which you are seeing is of 50 gram each, correct? And all the weights are of 50 grams each. So what am I going to do is, I'm going to pass this rope like this, and the knots being over here. Now I'm going to attach the weights. So I'm selecting 150 gram weight, so you'll be seeing this weight, that is 50 grams, and two more weight because all the weights are of 50 grams each. So that I'm going to put it over here. In the same way, 150 grams weight over here, and the unknown weight over here. This is the unknown weight. So this will come at an equilibrium position. Let it stay at its equilibrium position. When it stays at equilibrium position, then you see what am I going to do. So I'm going to use this formula right? And then I'm going to find the unknown mass with the help of this particular formula. So as you can see over here, there are two forces. Instead of F1 and F2, there are two tension forces which will be created inside the strings T1 and T2. And this tension force will be equal to this force. Let's call this as mg1, or F1 in the downward direction, F2, or that should be equal to m2g in the downward direction. This is m1g in the downward direction. Say this mass is m1, so m1g would be the weight downward direction, m2g weight in the downward direction. And this same tension would be equal to this, and this tension would be equal to this one. Now, since the resultant of these two is balancing this unknown mass, say m g in the downward direction, so two forces T1 and T2 having some angle between them, and if the system is in equilibrium, then its resultant, which is in this direction, should be equal to this force mg in the downward direction. So that means if somehow, if I know these two values and if I plug it over here, I can find out the unknown mass. And I would be requiring protractor in order to draw some of the angles and see how I do it. So now this mirror is to be kept behind this thread. And why it is being used? Because if you don't use the mirror, you won't be able to directly draw the thread. There will be some error. So what am I going to do is, I'm just going to close one of my eyes, and then I will see the image of this behind this one, and I will make sure that the image of the thread and the thread, they are actually matching, and I am putting two dots, one over here and another over here. Now I'm going to join this with the help of the scale. Again, I'll put this mirror and I'll make sure that the image of the thread and the thread are coinciding, and I'll put two ends. I'll mark those two positions. Again over here, like this. Now I'm going to remove all these things, and finally I'm going to join them, so I'll get the exact replica of this part. So now we have unmounted the entire setup. Now these 2 points I'm going to join with a straight line like this. Again, these 2 points are to be joined with a straight line, and finally these 2 points over here. So this represents the exact thread structure which we saw when this apparatus was mounted on the wall. Now I'm going to take a convention that say 50 gram as 1 centimeter. So on both sides, here we had 150 grams, here also we had 150 grams. We don't know what is the weight over here, and I'm going to take 50 grams as 1 centimeter. So 150 grams means 3 centimeter. So on the scale I am going to take 3 centimeter. By taking this as the center, I am going to draw an arc like this. Again, this is also 150 grams. So by taking 3 centimeters, again the same, make an arc over here. So now I have 2 points for completing my parallelogram like this. And since I want to make a parallelogram, and we know that opposite sides of the parallelogram are equal, so 3 centimeter and 3 centimeter again. So I'll make sure that the 3 centimeter reading has not changed. And by taking 3 centimeters from here, this as the center, I'm going to make an arc Again this, and taking this, making an arc over here. So this is the point of intersection. Now I'm going to join these 2 points and these 2 points like this, and my parallelogram is ready. And we know that the diagonal of the parallelogram is the resultant weight. So what am I going to do is, I'm going to make the diagonal by a dotted line. So the diagonal length is going to be my resultant, and the diagonal length is turning out to be 2.9 centimeters. So that means 2.9 multiplied by, I have considered 1 centimeter as 50 grams. So 2.9 multiplied by 50 is 145 grams. So the length of the diagonal is going to give me, in terms of the mass, as 145 grams. Now the actual mass is shown in the picture over here. That is 148 grams that I have already measured with the help of the digital balance. So there are slight human errors in the experiment, or else the experiment is fine. So in this entire experiment, even if these two weights are not the same, then also the experiment will go very smooth. And this is parallelogram, and by constructing the parallelogram we are doing this experiment. So hopefully guys you have enjoyed the experiment, and please do subscribe to my channel if you have not done so, and if you have any doubts please do ask in the comment section. Thank you for watching the video.